Good evening, guys. Welcome to Solutions to Academy once again, where we embody our motion, our motto for conviction to clarity and from text to testimony. Today, we are going to be talking about what equation of motion. So now, what do you mean by equation of motion? A mathematical expression connecting your displacement, your displacement, your acceleration, your velocity, and your time taking, and so on. So you're all familiar with those terms. So there are four equations of motion, and let's see how they are all derived. So the first equation of motion is derived from, let's first list it out. The first equation of motion is that what v is equal to u plus at. V is equal to what? U plus at. That's the first equation of motion. I'm going to be telling you how they derive all this as time goes on. The second one is what? S is equal to what? V plus U all over 2 multiplied by T. This is the second equation of motion. And the third one is that what? S is equal to ut plus 1 all over 2at square. And the last but not the least is what? V square is equal to u square plus 2ax. These are the four equation of motion from the basics of what? Of physics, which are the what? The knowledge of in what? Knowing scalars and vector quantities, motions, and the types of motion we have. Now let's go on. How did they know that what? V represent velocity, that is the final velocity. Your U represents your what? Initial velocity. Your A here represent what? Acceleration, and your T right here represent what? Time taking. Your S here represent what? Distance cover. Sometimes they use speed also, but sometimes we use speed. It depends on the way the question come. They might write speed and it will mean distance cover, and sometimes they might use speed and it will mean either of the two velocities. Be very careful of that. I want you to be seeing question on that. And we also have T to be what? Time taking. What again? A to be what? Acceleration, and so on. So your velocity, one that velocity is in what? The unit of velocity is what? Meter per second. While for your acceleration is what? Meter per second square. For ut also what? Meter per second. They are both velocity. This one is just the final velocity, and this one is the what? Initial velocity. Your s is in what? Meter, and your t is always in what? Seconds. You have to take note of the what SI unit of this. How will they derive it? So we said from what? From our basics, we know that what? Acceleration means what? Change in velocity over time. What change in velocity? Final velocity is what? Initial final velocity minus what? Initial velocity over time. That is, we have A is equal to what? V minus ut. Now cos multiplying from here, we have what? A times t. At is equal to what? V minus u. Now let's now make the u b inside the formula, the u will transfer. So we have what? At plus u is equal to what? V. Then rearranging this, we have what? V is equal to what? U plus at. Equation 1. This is this is for what? Equation 1. Now equation 2. We know that average. How do you derive equation 2? We know that what? Average velocity. Your average velocity is equal to what? U plus V all over what? 2. That is, the average velocity is equal to what? U plus V over 2. And your distance covered. You ask me what's the meaning of distance covered. We said what? Distance covered means what? Average velocity multiplied by what? By time. So since distance covered is equal to what? Average velocity multiplied by time, then we can say what? And our what? Distance covered is represented by what? S. So you can say S is equal to average velocity. What average velocity? U plus V over 2. U plus V all over 2 multiplied by what? Time. Then this is how we arrive at what? Equation 2. Hope you are following, guys. So for your equation 3, we have s is equal to what? Ut plus 1 over 2 at square. How do you arrive by this? Now we derive equation 3 from equation 2. We say that what? Our equation 2 say that what? S is equal to u plus v over 2 close bracket t. Are you getting me? S is equal to u plus v over 2 everything close bracket what? Close bracket t. Now you can now say from equation 1 we know that what? V is equal to what? U plus what? At. Now solve for what? V is equal to u plus at in this equation. So we have what? S is equal to, anywhere we see v we put what? U plus at. So we have what? U plus, instead of v we are going to be writing what? U plus at all over 2 times t. Now let's start arranging. We have s is equal to what? U plus v is what? 2u. Just like 1u plus 1 is what? 2u. Plus what? At all over 2 or multiplied by what? By t. Now splitting this, we have what? S is equal to 2u over 2 plus what? 8t over 2. You know that these two, as this one, if they both add these two, so we can split that is 2u over 2 plus what? 8t over 2. Everything multiplied by what? By t. Now 2 can now cancel 2. We have what? S is equal to, now t, now we multiply everything inside the bracket, abi. This one remain what? Ordinary u times t will give us what? Ut plus this one now. We multiply this numerator. At times c will give us what? At squared. So we have what? At squared over 2. So you can write this in this form, that what? S is equal to what? Ut plus what? 1 all over 2 at squared. You know that this is still the same as this. 1 times at squared is still what? At squared. So these are the what? The third equation of motion is derived. These are the third equation of motion is derived. Now let's now move to how what they get the what? The last equation of motion. This is the fourth equation of motion. Where should I go? Okay, let me go this place. So v square is equal to what? U square plus what? 2as. How they derive it? So we derive the last equation of motion from equation 1. Equation 1 said that what? Our equation 1 said that what? V is equal to what? U plus at. Now squaring both sides, we have what? All this sky square and everything square. We want to square both sides. Now we have what? V square is equal to what? U plus at multiplied by what? U plus at. So the square of this one means what? U plus at multiplied by what? U plus at. Now let's start opening the bracket. So we have what? V square is equal to u times u square plus u times at, at plus 80 times u plus what? U at plus what? 80 times 80 is equal to what? A square t square. Are you getting me? Now, so we have what? V square is equal to what? U square plus u80 plus u80 will give us what? 2u at. Like there is an invisible one right here, abi? U plus u80 plus u80 will give us what? 2u at plus what? Plus what? A square t square. Now from here we have what? V square is equal to what? U square plus, now what's common? Let's say, okay, you can take, you know that here a is common. A is common, right? We have a to be common. We also have what to be common. You can bring 2a outside right here. Yes, let's do it like that. You can bring 2a outside right here and say 2a into u80 will give us what? This one will remain what? Ut plus, because we want to let this bracket to resemble this our what? Our third equation. So we bring 2a outside. If you cancel 2 from here, remove a, it remain what? Ut plus. Now is there 2 here? No, but you can easily say 1 all over 2. So whenever you want to open your bracket, these 2 can easily cancel these 2 and it will remain what? Ordinary 1. Are you getting me? So now if a, we have a square and you have ordinary a right here, removing it will remain a 1a and your what? T square. Now checking this bracket now, you can see ut plus 1 over 2at square. And ut plus 1 over 2at square is the same thing as what? As s. So you can say v square is equal to what? U square plus to a s. Are you getting me? So this is the fourth equation of motion. So these are the four equations of motion are derived. Hope you are getting me. Now let's take question on this. Let's take question on this. Let's take question on this. So the first question, you can write it down. We have, sorry, let me take out the duster. So now we have a car start from rest. A car start from rest and accelerates uniformly 2 meters per second square. The car start from rest and accelerates uniformly 2 meters per second square for 5 seconds. For 5 seconds. Find I, the final velocity, I, the distance covered. So that's the question. Let's see how we are going to be solving this. So the question says that what? A car start from rest. If a body should start from rest, that is, the person is just starting, assuming you are just starting a car and you don't want to drive, that is your initial velocity right there is from a rest. Rest means that what? Your initial velocity is from what? 0. Are you getting me like that? So your u is equal to what? 0. And accelerate uniformly. We said what? It accelerates uniformly. Accelerate uniformly at what? 2 meters per second square. Meter per second square is used for what? Acceleration. So we have A of what? 2 meters per second square. We have A of what? 2 meters per second square. For what? For 5 seconds. Are you getting me? For 5 seconds. Seconds is used for what? Time. That is your T is equal to what? 5 seconds. You now have to find the final velocity. What final velocity? I think your final velocity is the same as what? Your V is your what? Final velocity. And distance covered. Your distance covered is what? S. S is the what? Distance covered. Now we know that your G is equal to 0. A is equal to what? 2 meters per second square. Your T is what? 5 seconds. Your V, you have to find your V and your what? Your S. Now how are you going to solve it? Then the first thing you have to look for what? For question number 1, the first thing you have to look at, you are giving U, you are giving A, you are giving T. You are now going to try B and S. So how are you going to know out of the equation which one are you going to use? So you are going to check the parameters given to you. So the parameters given to you will determine the kind of equation you have to use. Now I have U, right? I have A, I have T. I want to find V. Which equation connects U, A, T and V together? Are you getting me? So from equation 1, I have what? V is equal to what? V is equal to what? U. I have U plus what? A. I have A and I have T. So I can easily use what? The first equation of motion to solve for what? To solve for V. Now solution. So we have what? V. Using the first equation of motion, V is equal to what? U plus what? A, T. And finally V is equal to what? My U. My U is what? 0 plus A. My A is what? 2 times my T is what? 5. Are you getting me? Then we have V is equal to what? The 0 plus 2 times 5 is what? 10. V is equal to what? 10 meters per second. Never forget your unit. It will what? It will move your eye. You should forget your unit. So your V is what? 10 meters per second. As simple as that. And what? And the second you find your S. Now I know U, A, T, and V. I find it in my head. What is the formula for S? I said what? S is equal to what? You can easily use S is equal to what? V plus U all over 2 multiplied by what? Multiplied by time. Are you getting me? S is equal to what? V plus U over 2 multiplied by time. What you use? S is equal to what? UT plus what? 1 all over 2AT square. Any of the above, you are going to get the same answer. So we have S is equal to what? Your V. Our V is what? 10 meters per second plus our U. What our U? 0 over 2 multiplied by what? T. What is our T? Our T is what? 5. So we have 10 plus 0, 10. 10 divided by 2. 10 divided by 2 is what? 5 times 5. And 5 times 5 is what? 25. 25 what? Meter. I said the distance covered is in what? Is in meter. So they were asked what difference between what? Distance and displacement. They are both in meter, but what is the difference between them? The difference between them is just that your distance is a what? The scalar quantity, and your what and your displacement is a vector quantity. Watch out the next video on this. I'm going to be taking you all about what how to you really know the difference between what your scalar and vector quantity, and and those parameters are fall under what scalars and what and vector quantities. So we have s will be equal to 25 meters. So as simple as that, we finish question number 1. Question number 2. A body moving at 20 meters per second is brought to rest by a what? By a uniform retardation. By a what? Uniform retardation of what? 4 meters per second square. Find time taken, and B, find distance covered. Now see this question. It's quite different for the one first off. We have a body moving at what? 20 meters per second. A body moving at what? 20 meters per second. This is moving at 20 meters. Initial velocity is using to move is what? 20 meters per second. Are you getting me? From that 20 meters per second is now brought to rest. So in this case, your final velocity V is the one that is brought to what? Brought to rest, which is what? 0 meters per second. Hope you are following that. By a uniform retardation of what? 4 meters per second square. Meaning that meter per second square is different for what? Acceleration. But it doesn't not say acceleration, it said what? Retardation. What is retardation? Retardation simply means what? Negative acceleration. So you are given a retardation of 4 meters per second square. That is your A will now be what? Acceleration will now be what? Minus 4 meters per second square. As simple as that. Assuming you are given retardation of what? Minus 4 meters per second square, then your acceleration will be what? 4 meters per second square. Retardation means what? Negative acceleration. Find the time taken. You have to find the time taken T. And also what? The distance covered S. The distance covered is what? S. So how am I going to be solving this again? I have U, V, A, and T. Oh, I can easily use the first equation of motion also. So I have what? V is equal to what? U plus A T. But I'm finding what? I'm finding what? I'm finding T. So let me make T the formula. I can say, oh yeah, collect like sign. V minus of U is equal to what? AT over A over A. Then T is equal to what? V minus of U all over A. Are you getting me? Then we can say T is equal to what our V? Our V is what? 0 minus what our U? Our U is what? 20 meters per second minus 20, okay, over our A is what? Minus 4. So we have T is equal to what? Minus 20 over minus 4. Minus cancel minus is become plus. T is equal to what? 4 here 1, 4 here 5. So we have what? 5 seconds. As simple as that. That's the equation of best fit. And you have to find S again. You can easily use S. Which one should we use for the formula for S? Let's use S is equal to what? V plus U over 2 everything multiplied by what? Multiplied by T. So we have what? S will be equal to what our V? 0 plus what our U? 20 meters per second over what our what? Over 2 everything multiplied by what? Dt, which is what? 5 seconds. So we have S. We have S to be equal to 20 over 2. What's 20 over 2? 10 times what? 5. Then S is equal to what? 50 meters. As simple as that. S is equal to what? 50 meters. So it answer the question also. Now let's take another question. Let's take one more question before we call it a day. So you can take down this question. A car accelerates uniformly at the rate of what? 10 meters per second. It accelerates uniformly at the rate of 10 meters per second square from an initial velocity of 36 km per hour. From an initial velocity of 36 km per hour for 30 seconds. For 30 seconds, find the distance covered during the what? During this period. Very, very simple question. Find the distance covered during this what? Period. How are you going to solving this? So we have the car accelerates uniformly at a distance of what? Of what? 10 meter per second square. Accelerate uniformly. Your acceleration A, your acceleration A, your acceleration A is given to be what? 10 meter per second square. Your acceleration A is given to be what? 10 meter per second square with a initial velocity of what? 36 kilometer per hour. You are given a initial velocity of what? Initial velocity of what? 36 kilometer per hour. Don't forget, you have to convert it back to what? Meter per second. Okay? For what? For 30 seconds. Your time is what? 30 seconds. So we now have to find the distance covered during this period. You have to find your S. You have to find what? S. You are giving A, you are giving U, you are giving T, you have to find your S. So this one is in its unit, this one is also in its, let's convert 36 kilometer per hour to what? To meter per second. So we have what? U is equal to what? 36 kilometer per hour. Abi? So we have what? U is equal to 36 kilometer to meter is what? Multiplied by what? 1000 over hour to seconds is what? 60 times 60, which is what? 3600 seconds. Right? So 2 zeros can cancel 2 zeros. 36 can cancel 36. Then 1 times 10 will what? You use what? 10 meter per second. And you have to find your S. So you have to convert it times 1000 over what? 3600. Then 2 0 cancel 2 0. 36 cancel 36. It remains what? 10. So now, what formula can I use to calculate for S? UAT. Okay, I think that should be the third equation of motion. S is equal to what? UT plus 1 all over 2 AT squared. And this one might be wondering, what would I use my normal formula that I've been using, that S is equal to what? V plus U over 2, everything divided by T. If you check this question very well, there is no final velocity V. That's why I choose to use the word, the third motion. But as we have V, I usually take that shortcut and get it out. S is equal to what? UT plus 1 over 2 AT squared. So we have S is equal to, so what's my U? 10 times, what's my T? 30 plus 1 all over 2 times 10 times 30 squared. Right? So now I can say S is equal to 10 times 30, that should give us 300, plus 1 all over 2, okay? 2 here, 1, 2 here, 5. So 5 times what? 5 times 30 times 30. So 30 times 30, that should give us around 900. So 900 times 5 should give us 4500. So we have S is equal to 300 plus what? 4500. So we have S to be equal to what? S is to be equal to what? 4800 meter. Final answer. So 4800 meter. So sometimes, assuming this question comes in kilometer, assuming your options, I think we are doing an OBJ question. And you have to leave your answer in what? Kilometer. But not easily divide this by 1000. Dividing by the 1000, we have what? S is equal to what? 4.8 kilometer. That's your final answer. So meter to kilometer is what? Divided by 1000. Kilometer to meter is what? Multiplied by what? 1000. I hope you find this video very helpful using what? Equation of motion. Check out our next video. Don't forget to like and subscribe to our channel. Thank you.